Cutlass, right? And the topic name is wrapper classes. As we have discussed yesterday, as we started discussing Java.lang package. So from that package only there are few classes we have. Those classes are called as wrapper classes, right? So wrapper classes are those classes which are used, right? So from this package, so yesterday we have discussed some classes like string class, string buffer, string builder, right? And object class, just introduction to object class. Again, some other classes are there in this package, right? So the classes which are called as wrapper classes. There is no class. This is not a class name. Wrapper class is not a class name, right? So there are some classes which are used for converting primitive types to objects, right? As we know that in object-oriented programming language, when you, as we discussed, everything must be there in the form of, every data should be there. The data should be there in the form of what? Objects, right? So then, but Java supports the data in the form of primitive types. If you don't, if you want to convert the primitive data to their corresponding objects, and from the objects format to corresponding primitive types, so there are few classes are given for us, and those classes we call as wrapper classes, right? So this is fundamental to object-oriented programming. The data should be there in the form of what? Objects. Whenever you develop any program, whenever you write any program, right, the data must be there in the form of objects. But in Java we have data in the form of primitive types. To convert them to their corresponding object format, there are few classes are given for this, right? So these classes called as what? Wrapper classes. The name itself says wraps, right? Wrapping means covering, right? So we have different types of classes here. So byte is a primitive type, and the corresponding class for this is byte. And you have short, and the corresponding class type is short. You have right? So like this, for each and every data type, we have corresponding classes, and these classes are used to convert the data. Int, then long, you have, for this you have a class called as long. See the difference there, right? So all data types are keywords, and they start with a small, and the remaining are classes. They will have starting letter as capital. Then float, you have float, its corresponding class is float class. And then you have what? Double, its corresponding class is double, right? Then you have what is that? Char, and its corresponding class is character. And you have Boolean, and its corresponding class is Boolean. So like this, there are 8 primitive types. For each and every primitive type, to convert them to an object's format, 8 corresponding classes are given, and these classes are called as wrapper classes. All these wrapper classes are part of the lang package only, right? So java.lang package, see there, Boolean is a class which is used to convert a Boolean primitive type to what? Boolean objects, right? Byte again is a class which is used to convert a byte primitive data to byte objects. Character primitive type to character objects. Like this, you have few classes there. If you scroll through this, double, float, integer, long, right? And you have classes like short here, right? So these are the classes you have. So these are the classes which are used to convert from primitive to what? Object format. So if you see one class, that is enough. You can work with all the classes, because all classes works in the same way. Let us try to see integer. What is this? Class integer. And this is again a final class, and which is extends a class called as abstract class called as what? Number, right? So number is a class. Again, it is also from lang package, number class. So all number types of uh, all objects which represents numbers will be are child class of what? Number. Short, long, integer, float, double, byte. These are all child classes for number class, right? And this number class is a child class of what? Object class. So indirectly the integer class also a child class for what? Object class, right? So the subclasses of number must provide methods to convert represented numeric values, right, to what are their corresponding objects. Now here we see one class. So as I told you, if you see one class, in the same way all classes works. The integer class, what is this integer class is going to do here? The integer class wraps a value of primitive type int in an object. Means what? The integer class is going to convert an integer primitive type to what? Its corresponding object format, right? An object of type integer contains a single field whose type is what? Integer. So like this. So in addition to this conversion, very important, we have, in addition to this integer to int or int to integer conversion, the data can also be converted into what? Strings. As I told you yesterday, any object in the Java can be converted to what? String type, right? So it is what we have here. Now how to convert these integers to int values to integer types. So what is the advantage you have converting them? We'll try to understand here. As yesterday I told you, whenever the data is there in the form of primitives, one advantage I'm saying here, whenever the data is there in the form of primitives, you cannot call the methods on those primitive values. But if the data is there in the form of objects, you can call the methods to perform some kind of operations, right? So that is the one difference you have. Still it is passing the data in between the layers is also very easy in the form of objects, right, instead of raw data. Now here integer class, if you see, scroll through this class, you see some static variables, right? What are these static variables? So it max value, you can see there max value represents what? This max value represents a maximum value of integer range of integer, maximum range of integer, right? So min value represents a minimum value. If you want to call, how to call this? Integer class name dot max value, because it is a static variable. Class name dot max value, class name dot min value, and how much memory it occupies. If you want to know about this memory, and you can know about by calling again one more static variable given size, right? So this is what, if you want to know about integer data type more, right, you can use this class, right? So there are some constructors are given. See the constructors here. So these constructors takes the integer values. Again the constructors, if you want to create an object for a class, we require a constructor. Now there are two constructors, but interestingly there is no argument constructor. There these two constructors takes the values. These two constructors takes the values here, right? But there is no argument constructor you have in this, right? Now let us see here how to create the data and how to use these constructors, so that what I can do here, right? So there are lots of methods are given for this class. So once you have the data in the form of integer object, then you can call all these methods on this object, right? And all methods are, I can see, no, some methods are, few methods are static methods, few methods are non-static methods. So let's see here how to convert this data here, right? So public class, just I'm writing wrap int. So it is, this class is what I'm going to wrap the integer value to integer object, right? Public static void main string args, right? So is this correct? Can I write like this? 3 dots. Is it allowed? Writing 3 dots here, right? So I'm going to take int I is equal to some 33 something I'm taking there, right? I would like to convert this integer value to integer object. So If you want to convert integer value to integer object, there are two ways we can do, right? One way is, there is one constructors are given for you. With the help of constructors you can do this, right? So there is one constructor is given there which takes integer value, and which converts it to what? Integer object. Now I have already integer value here. Now I am going to pass this integer value to that constructor. What is that constructor? Integer constructor. For this I am passing the value here, and which converts this value to integer object. So whenever your data in the form of object, now it is possible to call the methods. As I told you, you can perform lots of operations on this object. You can call the methods, and but you cannot do anything with the I, right? So this is what you have. This is how you have converted the data into what? Integer object. Don't see the data will be same in the both variables, but one is available in the form of object, one is available in the form of a primitive. That is the difference you have, right? So both contains the same data, 33 only, but one has the data in the form of primitive, one is in the form of object, right? If you print this, absolutely it is also gives you the same data. Println of what, right? I'm going to print it I object, right? So I'm going to save my class dot java, right? I'm saving it dot java here. It's fine, the same location I'm saved it, right? So cd what is that? Online classes java c, what is it? Wrap int, right? It's fine, compiled. Java space wrap int. Oh sorry, should not use class there. Now you see this, the object is also contained what? The same value, 33, but you have more you can do what? More operations. You can perform more operations if the data is there in the form of what? Object. So this is one way to convert what? A primitive data to object format, and this is the most important one, right? So you can convert if the data is there in the form of string also, you can convert it to what? Primitive, right? So there is one more constructor. Which takes the data in the form of string. See this is the one I am using here. You take the data in the form of string, and from this it is going to convert it to what? Integer. So construct a newly allocated integer object that represents an int value, and that int value which is represented by string parameter, right? So this also works for you in the same way, right? But there is small problem you can face when you have the data in the form of string. When you have data in the form of string, you will face a small problem. That means if it is contains the data only integer data, then only it can be converted. If this contains integer data, then only it can be converted. If it does not contains integer data, let's suppose I have ABC. If I have ABC here, definitely it will not convert it to what? Integer. So in this case it throws you an exception called as a number format exception. So what is the meaning of this? We'll see here. What is the meaning of number format exception? We'll see later. So right, it is saying what? Number format exception. So whenever you have the data, see, number format exception. Whenever you have the data in the form of string, that string should contain integers only. Then only it is converts. Otherwise it will not convert it to what? Integers. You must have the data in the form of what? Strings. Then only it converts. Otherwise it will not convert here, right? So data must be there in the form of strings, integers only. Now it converts it, right? So it is fine. Now it converts it, and it stores that 55 in the form of what? It will store that 55 in the form of object, integer object, right? So this is one you have here. This is how you can convert these integers to what? Integer objects. There is one more way also you can convert them, right? There is one more way also you can convert them, right? So that is, so there is a static method in this class, right? So there is one static method in this class which takes integer value and converts it to what? Integer object. What is it here? Value of, what is it is taking? It is almost like what? Constructor only, right? But it is a static method. How to call the static method of a class, right? This method is static. See here, it is static. How to call a static method? Class name data, method name, and I need to pass integer value, and which gives me an integer object, right? So class name dot method name, I need to pass integer value again, which returns me integer object. Yesterday I have given such kind of methods are called as factory methods, right? Such kind of methods are called as what? Factory methods. So this is a static factory method. In the string class we have seen some static factory, non-static factory methods. So this is factory method. Now how to call that method? Integer dot value of, pass an integer value. I think I have integer value here. Again, there are two versions are there for this also, right? Two versions are there. So you can pass integer value, or you can pass the integer data in the form of what? String also. Both are allowed. Now it is going to, it will return you an integer object, right? So I'm taking the help of API so that you can, in the future you can use it, right? So it is same here. Both are doing the same. Value of takes integer value and converts it to integer object. So it is a static method from integer class. So I'm calling this by using class name, right? So if you print it again, I will see 33 inside this. I value is 33 because, and you will see 33 inside the object form. 33 will be there in the form of object form, right? So this is what you have here. And value of method, there is overloaded version is also available for you. Where is it? This one, right? So which also takes like second constructor, the constructor which takes a string. In the same way, value of method also takes a string and converts it to what? Integer value, right? So like this you can call these methods integer dot value of string, right? So these are the two ways you have here. And one more value of is there which takes a string and radix. Radix means here this is what? Base 2, base 8, base 16, like this, right? So that is what we have. So there are three different ways you can convert, two different ways you can convert an integer value to an integer object, right? So what is this here? So in a pictorial, if you want to represent in simple, you can represent it in the graphical way. So this is int and this is right. This is int data primitive, and this is integer primitive, right? Now, so for converting from int to integer, you can do this, right? Right. So we use what here? Converting from this to this, we use what ways you can do? Constructors is the easiest way to do this. Constructor, you can go for constructor, or second one is what is that? Static value of method. Value of. There are two ways you can use any one, constructor or static value of method. So which converts int value to integer data type, right? So this is my source and this is my target. It's fine. If I want to convert back, from this to this, if I want to convert back from int to integer object to int, so what should I do here if I want to convert back? So right? So what should I do if I want to convert back this one, right? What methods have? So what is my source here? My source is integer object, but the target is what? The primitive data. Now how can I do this? My source is primitive and my target is, so search for the methods where the target should be primitive and the source should be, there are few methods you can see here, right? So here we have some methods called as xxx value methods, which can do for you, right? See here, what is this here? Where is that int value? Yeah, so this is a non-static method. What is this? Non-static method. How to call this non-static method? This non-static method should be called by using a object of that class, right? This is a non-static method from integer class. Returns, what it is going to do? Return the value of integer as an int. Returns the value of integer as an int, right? So you have a int value, and it is a non-static method. If you want to call the non-static method, you require the object of that class. So already I have that object. What is that object? I object dot, what method I need to call? Int value. Int value you have here, which converts it to an integer. Which converts it to an integer. And this integer is k. Right? So non-static method, it is a non-static method from integer class. So I am calling this by using integer object, and it returns me an integer value. Right? So this is how you can convert back your object form to an its equivalent primitive form, right? Convert like this. Yes. So this 33 is in the form of object. The first 33 is in the form of object. The second 33 is in the form of what? Primitive value. Getting me? Right? Just conversions. So there are few conversions which are important for us. I will give what conversions are important for us, right? So not all conversions are important. Now this is how you can convert. And interestingly, now if you want to convert a object, if the data is there in the object format, so it is can be converted to what? Different types also. Integer dot byte value. It will convert it to what? Its corresponding byte, right? Let's see if I have 333, right? Okay, it's fine, because 333 can be converted to integer, and it can be converted back to what? Integer. But if I try to convert it to a byte value, is it going to give me 333? There is a byte value method which converts it to what? A byte. Is it going to give me byte here? 333? Right? What is the range of byte you have here? No, right? Range 333 cannot be fit into what? 333 is not between byte range. It is out of byte range. So we have discussed that day when I have given typecastings, that I have discussed. Yes? So this is what we have here. Now it is not 333, it is converted to 2's complement, and it is using some kind of algorithm inside, and it is converts it. So any value, any object can be converted to what? Any data type, right? So for this we simply use the methods, and these methods are called as, right? So what are these methods are called as generally? So int object can be converted to int value, it can be converted to byte value, it can be converted to what? Long value, it can be converted to short value, like this we have, right? So these methods are called as xxx value, so that xxx can be replaced xxx value, right? So this is what we have here, xxx value. They are non-static methods, and They should be called by using objects. Object of integer object. So here it is not int actually. So okay, fine. It's not int here. Here you have what? Actually, this is not int. So you can say these things works for any primitive type. Right? This is primitive data. Not only integer. That is not int actually. It is entirely primitive data. And this is wrapper object. Or primitive object you can say. Right? So these methods not only works for integer. Wrong. This is for primitive object I can say. So these methods works with all primitive classes. Don't take it for only integer. I am taking the example of integer. That is wrong. Right? So primitive data, primitive object. Right? So any primitive object can be converted to what? Primitive data. But one important thing to be noted here is you cannot convert booleans to any other format. Booleans can be converted only into boolean objects. Booleans cannot be converted into any other format, or any other format of data cannot be converted to what? Boolean format. It's not possible to convert the data into what? Boolean forms. Right? It's not at all possible to convert the data into Boolean forms. And characters, yes. There is no characters. If you see the character class, in the character class, what is that? Character primitive class, you don't have any constructor which takes a string and which converts it to what? A character. Right? You don't find any string which takes a character and which converts it to what? Which takes a string and it converts it to character, because group of characters cannot be converted to a single character. No. Right? So this is not there. This constructor is not there in that character. So remaining all classes works in the same way. Right? So Boolean cannot be converted to any other format, or any other format of data cannot be converted to what? Boolean format. Right? So this is what you have. Converting from what? Primitive data to their corresponding objects, and from their corresponding objects back to what? Primitive data. In the same way, the data can also be converted to one most important type you have. That's what yesterday we have discussed. Yesterday I have told you. I think I have given some assignment. I don't know how many of you researched on that. How many of you solved that? String. Any data in the Java can be converted to what? String format. Most important conversion here you have. Right? Now, so the data can be converted from primitive to string format. Absolutely, you can do this. And at the same time, you can convert your data back from primitive to string format. In the same way, you can do this conversion also here, from this to this, and this is the most important conversion. The most important conversion. This is the one. And this to this. Right? So what is this methods we use to do this? Again, not all are important here. Right? So what is these conversions we use here? So my source is, let's suppose my source is primitive data, and I would like to convert it to what? String. So my source is primitive data, and I would like to convert it to what? String. And here this is reverse, this is this, this is what's wrong here. Right. Now what methods I have? Just need to search for these methods which converts into what format here. So integer data to string format. What is that method which takes that integer data and which returns me a string value for this? Right. So there are, right, see here. See this? A static toString method is there. Static toString method is there which takes an what? Integer data as input and which converts it to what? Its string format. So how to call this static toString method? Again, this is from what? Integer class. So how to call this static toString method to convert integer data to string? Now let me use this static toString method, right? Because it is static method, class name is required. Integer dot to string, and I need to pass some integer value. I have passed it, and which returns me the data in the form of what? String some str1, because str is already there, right? Now the data is converted into what? String format. System dot out dot println of str1, right? Just I'm printing it. Now I'm going to do something here. I'm going to add something to it. Let's see. So what happens here? The data which is there in the str1 is what? 333, and I'm adding something to 333. So what would be the output I will get here? What would be the output I will get in this case? (333 + 10). So what is the output for that? (333 10). Okay. Yes, absolutely it is 333 10, because the data is there inside. 333 there is in the form of what? String. So when the data is there in the form of string, it is concatenation, right? So this is what you have here, right? So it is concatenation. So the data is converted to what? String. Integer dot toString. So this is what method here we have, from which to which? Primitive to string. So what method we have here? Static toString method. Is a static method, right? And okay, this is fine, right? Static toString method you have is here for this. Now what is this here? String to primitive data. So what is my target? Source string object, and the target is primitive data. And this is the most important conversion. The most important conversion, we regularly come across this, right? Source is string and target is primitive data. Right? Search for the method which is going to do for this for me. Right? So source string object and target is integer value. Most yes. I find it here. Static parseInt method. That static method parseInt, which takes a string and converts it to what? Integer. So how to do it now? How to convert it? Very important. So because it is a static method, again class name integer dot parseInt. Takes you what? Take a string object, right? Now what is my string object? Okay, my string object is str1. I'm passing str1, which converts it to what? Which converts it to what? Int value, right? Some L. Now I'm going to do the same here, but it is now L plus 10. Now what output I will get inside this now? So str1 I converted back to integer and I'm adding it. Most important conversion. Most important conversion. Everywhere we come across. In advanced Java, very often we come across this conversion. What is the output I will get here? Right? 343. Yes, it is 343. So in the string, what we have? 333 and plus 10, 343. So converting, this conversion is very important, right? Everywhere you come across, especially when you learn advanced Java, you will come across this conversion. Not only integers, string to primitives, integer, but anything, string to any data you can convert. Strings can be converted to any data here. But don't think that whatever you have here, A, B, C, D, those also can be converted to what? Integers. No. This string object must contain a integer value. You cannot convert integers, A, B, C, D, X, Y, Z to what? Integers. No. If you try to convert like that, you will get a number format exception. If that string object has what? Integer value, then only you can convert it. Other than integer value, you cannot convert it. Long value or float value, then it's okay. Integer value can be converted to integer, float value can be converted to float, double value can be converted to what? Double. So what is it? So this is how you have here. Integer dot parse int. The same way, integer data, a float dot parse float, double dot parse double, byte dot parse byte. Like this you will have. Careful here. The most important conversion we will come across. Remember this, integer dot parse int. So how to convert a string to an primitive here? How to convert a string to primitive? We take the help of static what methods? Parse int methods, which takes a string object and converts them to what? Appropriate, not parse int here, sorry. This is parse xxx. Xxx can be replaced with the data type. Integer dot parse int, double dot parse double, float dot parse float, like this. Most important conversion you have here. And we'll very often come across this conversion in developing, right? So this is the one start for this conversion, right? So this is very important, parse xxx conversion, right? So next you have this objects conversion, string to primitive object and primitive object to string object. So string object to any, yesterday I told you, any object in the Java can be converted to what? String. Any data in Java can be converted to string format. Very, very important mechanism. Any object in Java can be converted to string. Right? That is the reason why strings are taken as objects. Any data in Java can be converted to string here. Now we'll see how to convert primitive object to a string object. How to convert a string object, what? The data in the form of object to a string object. So how to convert it? See, to string. It is a non-static method. How to call this non-static method? By using a object reference. And very important is, already I told you this toString method is from what class? This toString method is overridden from object class. In the object class you have this method. I don't know whether you remember it or not. This toString method is there in the object class, and from that object class it is overridden. From that object class this method is overridden, right? So what is this? So this is the method which converts the blind point and most important point, right? And any time you should be able to say the answer. In Java, any object will be converted to a string object. Any object in Java can be converted to a string object by calling toString method on it. It's not only this toString is not for only integers or floats or not only primitives. Any Java object, student object, account object, any Java object can be converted to what? String format by having this toString method in that class, right? Now here, so that primitive object to what? Most important. Primitive object to what? String object. It's not only primitive object to string object, it is what? All objects can be converted to target is string. When you have your target is string, it's a blind method to be remembered here, and most important method. What is that? ToString method. Any object in Java can be converted to string format by calling this toString method, right? So we call this toString method. Now what is that? So I require an object here to call this. Is there any object? Yeah, here I have integer object. Here I have what? Integer object. Now, is it integer object? Yeah. From this integer object, I want to convert it to what? String object. I obj dot calling a toString method on this, it will convert it to a string. It's the most important conversion. str1. Right, now I append this str1. Spelling mistake there. It is, first of all, it is not I object 1 I want to print. I want to print str1 small s. And here one more mistake is, this is not small o, this is capital O. It's fine. 333 in the form of string. Now if you add something to this, now I can see its concatenation 222. Three, 222. Most important conversion and most important interview point of view question is, it's not only primitive object, any object in Java, any Java object can be converted to a string by having toString method in that class, right? So what is the last one we left with? The string to object. The data is there in the form of string, how can I convert it to a object? Again the same thing here. I think we use the same method. What is my source and what is my destination? Source is string and destination is object. Check for the method which takes a string and which converts it to object. Yes. Value of method is enough. Value of method is going to take the string and it is going to convert it to an object. The first one only. Or any other methods you have? This value of method only can do for this. Can do this. String to integer. So you can use the value of method here. What is this? Value of same. So this value of method can help you. And out of all these conversions, we don't require all in the development. This is the one conversion you come across. This is the second conversion. These two are important for you. Right, this is how you can convert primitives to objects and objects to primitives, and primitives to strings and strings to primitives, like this. Different types of conversion we have. So in the previous already we have seen such kind of conversions where we have seen uh, primitive conversions to primitive conversions, right? The data in between primitives we have seen. And here we are seeing the conversion between primitive data to objects and objects to what? Primitive data. Okay. And not all conversions are required for you guys. These two are important for you. You understand what I'm trying to say here? I'm not getting any replies today. Every day I will get the replies. Yeah, only one active. What happened? Remaining. Hmm? There are not. Fine. Right. So this is what you can convert here, but no need to do all these headache. So whatever you have these conversions, this conversion primitives values to primitive objects. This is up to 1.4 people used to do this. People used to do this conversion up to 1.4 of Java, but in 1.5 Java people has introduced a new concept. So in between only primitive data to what? Primitive objects. In between only primitive data to primitive objects. In Java 1.5 there is a new concept is given, and that concept we call as. So whenever we want to convert primitive values to primitive data, no need of remembering these methods and converting them. No. Still the string conversions are still like that only. String conversions are still like that. Still you need to do in the same way. But when you have the conversions in between primitive data and primitive objects, so no need to use these methods, right? So for that you have a mechanism called as, right, a new concept is introduced in Java 1.5, right? Again, this is also one important interview, auto boxing, and what? Auto unboxing, auto boxing and auto unboxing, right? Auto boxing means converting primitive value to primitive object, and auto unboxing means converting a object to value. Same concept, but in a different way. It is completely automated, right? So no need of, as a programmer, you no need to do explicitly these conversions. So the Java is going to do these conversions for you. Auto boxing means what? Automatically it converts the primitive value to object, and unboxing means what? Object form to value. So how it is going to do here, we'll try to understand. So this is also not a new thing for you. It's already you have come across such kind of a conversion here. So up to now we are using some constructors or some kind of methods to do your conversions, right, in between primitives and all. Now it is not required. So whenever you assign, right, so here, so if you want to store a integer value, if you want to store a integer value, integer data inside a integer variable, now you use this kind of syntax, right? So integer value to a integer type. Same such kind of syntax is introduced. Already we have seen string data. If you want to store a string data into a string type, then we can directly, string literal can be directly stored in the form of a string object. This is what we have seen in the strings. Same kind of syntax which is given for you, which is going to store. No need of using any constructors. Integer I object is equals to, directly you can store the data inside this object. No constructors, no new keyword. Now this is what? Data to object. So this is called as auto boxing. Data to object, this is called as what? Auto boxing. And object to data, int I or int k is equals to I object. This is called as unboxing. So same mechanism, there is no difference in between these two, but so it is completely automated for you now. No need of using any constructors and all. So the Java internally is going to convert it for you. The first is I object, the second is k. Both contains the same data. Both contains the same data. So whenever you write like that, Java internally is going to convert it. 10 and 10. Called as what? Boxing and unboxing. But this is not, this is introduced in Java 5. Now if you compile your program, so you can compile your program targeting to some other versions of Java also, 1.4. So I would like, what is the meaning of hyphen source here? I would like to compile my Java program by using 1.4 compiler. So whenever you use 1.4 compiler, it is not there. This feature is not there. So the 1.4 compiler will give you an error. See, if there are two errors it is showing you, because this is not there in 1.4. This is called as what? Variable length arguments. Variable length arguments, variety methods are not supported in 1.4. Use source hyphen 5 or higher to enable variety methods. Okay, this is the first problem I have. So I am changing it to constructor, that I don't want to test that one. I want to test this one. Again the same story, two errors saying what? You don't have these types, incompatible. Integer data and integer object, they are not compatible. This is data and this object form, how it is compatible? No. But now if you compile this with 5 or greater, you will get it. Right? So it's fine now. It's compiled. One warning it is giving. That's fine. Right? So if you don't use this also, now it will be compiled with Java 7. It's fine. Right? So new concept. Boxing and unboxing. This is called as boxing, primitive to object form, and object form to primitive, called as unboxing. Okay, so no need to explicitly do this, but string conversions are still same. There is no other way to convert strings. You need to use parseInit methods or toString methods to convert this. Right? Okay. So let us try to see more about this. Let me write one static method. So as we have completed static methods, I am trying to add a static method to this class. Static returns me an so that's what I said, right? When the data is there in the object format, you will have some other extra functionalities. You can call the methods. Can I call I dot something? If your data is there in the form of I, can I do I dot? Can I call I dot something? No. But if the data is there in the form of object, can I call I object dot something? So the operations are a bit easy for the programmer, calling the methods and all, converting one format to other format. By simply making use of methods, you can convert them. Okay. So using the data is a bit simple when you have the data in the form of objects. In the raw format, in the place of raw format, if you have the data in the form of object, it is very easy to use. Now I'm writing a method here, static integer, let's suppose method is name is add, which takes one integer object. Let's suppose object comma one integer value, and I would like to add both. Right, I would like to add both here, and which returns me an integer int some new is equals to object plus value, object plus value. And because this method expecting me a return value, I need to return something here, and new. Okay, now can you say how to call this method? The method name is add, which takes one integer object, which takes one integer value, and which returns me an integer object. Okay. This is a keyword, right? You should not use new because it is a keyword. Okay. Total. How to call a static method? Right. So static method should be called with class name. Just method calling here. What is there? But there are two static methods in my class. One main method, another static method. Now a static method can be directly called from other static method. No need of any class name because both are there in the same class. 10, 20, and it returns me an integer. I'm storing into some temporary variable. Right. So what is the output I can get here? System.out.println of temp. Is it first works or not? A static method of a class can call other static methods directly. So add is the static method. I'm calling this add method from main static method. No problem. Is this method call is correct or wrong? It is correct only, right? So this 10 will be converted to, it will be auto boxed, right? And this is very normal. And when it is trying to add, it will be unboxed. Unboxed to what? Java is going to do all these things. This is unboxed and it is added to what? 30. The result will be saved into integer. And when it is again returning the value, it is boxed. So converted from object format to integer, integer to object, and object integer like this. Whenever it is required, Java is going to do these conversions. It is from 1.5. Right? This is fine. It is fine here. Now if you run this, it works. You get 30. But if you try to compile this with 1.4 version of Java, it will not work. .4 version of Java, if you use to compile this, it will not work. Where is that 1.4? This one. See, it is saying what? You cannot use How the objects can be added? It's not possible to add the objects, right? It is saying clearly bad operand. What is the meaning of adding a student object, student one object with student two object? You cannot add it. But still I am doing here. But it is 1.5 concept, right? So incompatible types, because your method expects a integer value, you are returning a int, and it is not correct to call add method, because add method takes integer and int, you are passing two integers, but it is fine with 1.5 or later. That works in Windows only. Command prompt F7. Right? So this is absolutely works here. Auto boxing and auto unboxing. Right? So this is what we have. Now we have come across various concepts yesterday and today. Now let me ask a few questions yesterday and today's session. Right now, I'm going to write. Nothing is there. This is boxing and unboxing. Converts automatically in between primitive data to in between primitive data and primitive objects. That's fine, right? Now let's see here. Now I'm going to write my methods like this. Right? My first method is like this. Void method int. Void method int, right? And one more method I have, void method integer. So the data type first one takes is int value, the second one takes integer value, right? Assume that these two methods are there in the same class. That means are they overloaded? Are these two methods are overloaded? Yes. Now if I call these methods, how to call these methods? Let's suppose I have created object for the class, object.method. Now if I pass 10, if I pass 10, which method will be called here? Integer. So I wanted to say the data will be auto boxed to integer type. Right? It is not integer. It is exact match. First preference will be always given to primitive data. If it is there, then it is int only. Then only integer. Because it is the newly introduced concept. If it is given preference, if it is given more preference, what happens here? Already written codes will not work. If the new concept is given preference, what happens? Already written codes, what happens to the already written codes? They will not work, right? So that is the one point you have here. So first always give the preference to the primitive data. If it is not there, then only it goes to what? Object form. Now I'm going to write one more version of this. Let's see what happens here then. Void method float. Are they overloaded? Now these three methods are there. Are they overloaded? No, not overloaded. They are overloaded, right? Data type is change. Method name is same and the data type is change. They are overloaded. Now if I pass 10, what happens in this case? Which one gets called here? These three are there in my class. Which one will be given preference? Int is called. Okay, fine. First preference to be int. If that int is not there, int method is not there. Assume that this method is not there. Integer. So first preference will be exact type. So he's saying like this one will be called first. If it is not there, out of these two methods, only these two methods are there, then somebody is saying integer will be called. Everybody says the same, right? So it is not integer, it is float. It will not call integer, it will be float. So first preference will be exact match, then implicit conversion, then only wrapper, auto boxing. Just now I have told you, right? Old concept will be preferred more. Right? First one is what? Exact match. Second one is implicit conversion, then only integer. Okay. So this one will be given last preference. Which one? Integer one will be given last preference. This one will be given last preference. Right? Now I am still going to write one more method here. That's what I am saying. This is primitive data, this is object. That is what wrapper classes we have seen up to now. This is a class. Integer is a class and this is a primitive type. Right? Void. I'm going to write one more form of this. Very interesting. Dot dot dot. Yesterday we have seen variable length argument. Are they overloaded? Are these four are overloaded or not? Yes? Yes, they are overloaded. Absolutely they are overloaded. Now which one will be given first preference? Which one will be given next preference? These are some few confusing questions, tricky questions. This is overloading again because this is single integer, int value, this is integer object, this float, and this is group of integers. Absolutely overloaded. Now which one will be given first preference? Exactly the first preference will be given 1, 3. First preference will be 1, second preference will be 3, third preference will be 2, not 3, not 4, and fourth last preference will be given variable length arguments, because it can be called by passing one integer, two integers, or n integers. But variable length arguments will be given least preference over auto boxing. Though they are introduced in, both are introduced in the same version, but this is having a least preference, right? So that is what you have here, auto boxing and unboxing wrapper classes and their importance in the overloading, right? So this is what here you have here. First preference will be exact match, then implicit conversion, then auto boxing, then variable length arguments 1, 3, 4, 2, right? So this is overloading, right? So this is what you have wrapper classes, and how what their use and how to use it. But out of those things already, as I told you, string to integer values conversion, parse XXX methods, and any object to string object conversion is very important to string, right? So this is what you have here, and today we'll see still one or two 1.5 features. So this is also 1.5 feature. We'll see one more feature of 1.5, right? And that feature is called as, so this is all about wrapper classes. Nothing is there, conversions in between primitives to objects. Now we'll see one more 1.5 feature that is called as covariant, what is it? Return types. Covariant return type. Covariant return type. What is the meaning of covariant return type? Already we have, you know that return type mean, right? So covariant return type. Whenever we discussed overriding, right, this concept is related to overriding. So whenever we discussed overriding, there are some syntactical rules I have given. What syntactical rules I have given for overriding is, so overriding happens in between super and subclasses, right? So re-implementing the superclass method in the subclass is called as what? Overriding. And when you do this re-implementation, method name should be same along with what? Arguments. As well, return type also should be same, right? So method name, arguments, return type, not only that, access specifier. But when we discussed visibilities, access specifier, there I told you, access specifier must be equal or access specifier also must be higher, right? So public method cannot be overridden with the default or private or protected, right? Always public method should overridden with what? Public only. That is all. That is what I said that time. But when you do this overriding, there is one updation there. One updation there is this overriding in 1.5, right? So that is what? Covariant return type. Now if I have a method like this, let's suppose my method is like this: public int and some method name, okay, add, which takes integer comma integer, some logic inside this, right? And how to override this method? If I want to override this method, how to override this method? How to override this method in the child class? String. String. Right? So if you want to override it, we should always override with the same syntax. Public int add, passing int comma int, like this only we should override, right? So this is how we should override this method, right? But if my method is like this, if my method is like this now, public my method returns a account object, let's suppose account object, and get account, and which returns an account object. Now how should I override this method? But so as I told you, it should have the same return type. Now it should override with the same type. HCCOUNT account, get account. You should always override with the same visibility or higher visibility, and return type also should be same and with the same account name with the same method name and parameters. But when you have a return type, when you have a return type as object, right, now you can change this object. That is the meaning of covariant return type. It is not works with primitive data, it works with only object. When you have a return type as object, you can override, you can change this. Its overriding method can return same object, it can return same object, or it can also return its child class objects. Saving account, let's suppose savings account, so it can return its child class object also, right? So whenever you have superclass method which is returning a object type, while you override it, so the overridden method can return its child class object also, exact or its child class, but it should not return what? A superclass object. No, it should not return its superclass. Object is a superclass for all the classes, and it should not return its superclass, where it can return exactly the same type, or it can return its child class. So this is called as covariant return type. It will not work with primitive data, it will work with only objects, right? So this is again 1.5 concept, covariant return types. So we have seen yesterday few concepts related to that 1.5 variable length arguments and enhanced for loop, and today we have seen auto boxing, auto one boxing, and covariant return types, right? So these are all 1.5 concepts, right? Getting me what I'm trying to say here? Right, this is the one more updation you have. So whenever you override a method, instead of writing its exact class type, you can return child class also, right? So this is one more you have in the 1.5. You can write like this, and still you have some other things in 1.5, like one more very small static imports. You have a concept called as what? Static import. So we are seeing imports up to now, but what is the static import then? Right? So we are seeing only import. Then one more is added to this one, that is static imports. Before seeing this, how to use this, let me go through the API once. Math. There is a class called as math in the lang package itself. Right? Math class is from lang package, and if you see this class contains all static methods. Contains all static variables as well as what? All static methods. So if you want to call, let's suppose I want to call a method called as what is that method? Any method you can call here. Now let me call this maximum, which takes two integers and gives me greater of two numbers. Static method from math class, and I would like to call this max method, which takes two integers and it returns me greater of two numbers, right? Now how to call this? Yeah. Now because that is a static method from math class, right? So I'm going to math example something here, class name. Now because it is a static method, I need to call with the class name math dot, what is it? Max is the method name, which takes two integers, right, and returns me the maximum, returns me an integer value only, int I. Now this int I will have the maximum of these two numbers. That is the method name, system dot out dot println of I. Let me compile and run this program. Java C, math example, it's fine. Java math example. You got the maximum number, right? 10. 50 if I give, It will return you what? 50. Static import. What is the meaning of static import? Right. So whenever you want to import the static things from a class, static variables or static methods, right, you can import them. Right. So you can import them. Right. So what is that? Import static. The class is from java.lang package and the class name is math. So this is how you import the things. Actually, when you write import, we use up to class only. But from this class, I want to import statics. What I want to import? Max. I want to import a method called as max. This is import static. Now, whenever you import it, now no need to use class name. No need to use class name to call that static variable or static method from that class. Import static java.lang.math. From the math class, I want to import a static method called as what? Max. Let me compile this. Is it correct or wrong? Let me check. It's fine. See, it is working in the same way. Right? So I did not call this method by using a class name. Still it is working. Let me make it to some change it to 105 and 105. So whenever you want to import the things from a static, it works with only static. If you want to import the static variables or static methods of a class, just you need to use what? Class name dot the method name or variable name which you want to import it. So when you import like this, no need to use any class to call this method. So this is the method called from what? Math class without using the class name. Right? So if you want to import all, now you can use simple star. Star means import every static variable or static method from that class. Getting me? Right? Now it works. Same output you will see. But now I did not use any class name to call this static. Why? Because I have used static. If I don't use static, this raises you an error. You cannot use this syntax. It is wrong syntax. Cannot find symbol max. Why? Because it is a static method. It is not unable to find. So you need to use static. So it works with only importing the static variables and static methods of a class. It's not recommended to use anyway. It's absolutely not recommended to use. Instead of decreasing the readability of your program, it confuses you a lot. Right? But this is the feature is there. Just I'm explaining there is a feature called a static import. Okay, fine. So now in the math class, whatever the methods you want to call, absolutely you can call without using any class name, because I am importing star here. If you see some other methods, you have square root, which takes a double value, sqrt, right, to perform all mathematical operations, which takes a double value. Let me give 4.0 and returns me what value here? This square root returns me double value. So I'm going to store it inside a double D. So without using a class name, I'm calling this square root also, because I'm importing all the methods of that class. Math example, termination, right? So this is one more feature which you have in 1.5 or 5.0 of Java, right? So that is what you have, right? So wrapper classes, auto boxing and unboxing, and some features of Java 1.5. Right, guys?